Welcome back, everybody. We are working on Unit 13 tonight. This is the first of four different project units that we have available here at the end of the course. Um, this one is entitled AI Project 1. The focus is working with statistical data. We will explore some very interesting no-code tools tonight. Most importantly, probably, is the orange data mining tool, which we were just talking about. Um, and we'll basically have it access information, and then we'll visualize it and manipulate it and stuff with that environment. If we do get to the point of demoing that portion is basically uh, part of the work for this class. So I'm going to actually skip ahead to the work portion here. So we do have a regular assignment in this unit. We do have a regular quiz in this unit. These are pretty normal. Um, and we also have a couple of data files here that apply to one or the other pieces of homework, or both, I forget. And then we also have the project. So there's homework, a quiz, and a project. So three deliverables in this unit. That's true for all units going forward. 13, 14, and 15, of course, all have that. 16 has it too, but with 16, all the work is extra credit and optional. The three different project categories we're going to focus on are statistical data, natural language processing, and computer vision. And then Unit 16 focuses on the future of AI. And once again, we have a week off in the middle of all this. And so keep in mind, I do have everything video recorded from last year if there's stuff that we happen not to copy. I still have an infographic that I'm going to be adding to this unit. I have it generated. I just didn't OCR it yet. So you guys will be seeing that in here too. I think those are kind of helpful. And if you guys don't know what I'm talking about, it's like I've been generating, these infographics with Notebook LM, which kind of summarizes all the content of the unit into a graphic. And I think sometimes that's okay. Sometimes a picture tells a story better than words, and so that's why I've been kind of including them. I don't know if you guys find those helpful or not. All right, since we have a lot of stuff to go through here tonight, I do have the PowerPoint here somewhere queued up. So let's go ahead and get into slideshow mode, flip the screen as per usual, and do a little adjusting here as we get started. All right, let's do a little screen arranging, get it out of the way of my chat window and stuff. All right, let's dig into the PowerPoint here. We've been going through a lot of stuff, but we are kind of at the point where we're not necessarily going to absorb a lot of new concepts at this point. We're going to look at tools, how they're applied, and how to solve problems with them, which is what the project units are all about. And the main focus for tonight is really working with statistical data, right? And as you guys have learned, AI can't do anything without data. It trains on data. Most of the determinants in artificial intelligence are based on probability, which comes from statistics, right? And that's why you also take an extra math course in this program for statistics. We'll be looking at no code tools, and once again, in particular, the orange data mining tool that's part of the Anaconda distro. All right, let's start to dig into this content a little bit. And like I said, I'm going to try to do this quickly, but I tend to get a little long-winded, so you guys already know that about me. But I do want to cover the content, right? So we want to hit the material. Please feel free at any point, drop stuff in the chat, unmute and ask or whatever. And we were introduced over the last few weeks to a number of different no-code tools. I hope you guys had fun with that teachable machine thing. That was kind of cool and different, right? And I don't know if any of you guys took it any further, but it is totally conceivable, by the way, to take the training you do in the teachable machine, which I think is such a cool thing that Google offers it for free, where you can train a model pretty extensively, like to recognize certain images or objects or gestures or whatever you can imagine. And then it converts it into code. And then you can grab that code that you just trained, right? And put it into a program, feed that program an image or a video stream or whatever, and have it determine what that object is. Like, wow, right? No coding required. well, if you're going to turn it into a program, there's going to be coding required. But at least the training part of it, there's none of it, right? And I think that's really kind of interesting. Here's some popular examples of no code tools that are specifically designed for working with statistics and statistical data. Some of these you might recognize, and others that you probably have not heard of, right? In this program here, we do teach you a number of different types of no code tools and visualization software. Tonight, we will probably focus on this more than anything, time provided. And then later on in your program, you do learn how to use this tool as well, which is RStudio. RStudio runs a language called R, which is a variant of Python designed for doing visualizations and working with statistical data. Okay, why is no code cool? Well, for all the reasons we've already talked about, right? You don't have to really know how to program. Okay, but if you do know how to program and you understand the concepts, it makes you even more powerful with it, right? And people who get it can work so much faster in these interfaces. So when you're like, well, why are we learning Python if there's no code tools? Because you'll be even more powerful with the no code tools that way. Everything's like click and drag and drop and adjust and set levels and whatever. You can very quickly learn how to use the tools, which is really another good thing. And they have this acronym here, MVP, where you can quickly create a minimum viable product, right? So you can kind of, without doing a lot of work, but understanding the concepts, you can use these no code tools to spin up solutions that can do things that can really benefit you, right? So this is really very advantageous way to work in the modern world. They have examples here of 4 different companies. Some of them you might recognize, and how they're using this type of technology to make their world better, or their job better, or their enterprise better. Seagate, a company that makes a lot of like hard drives and stuff you guys might be familiar with, they have a no code tool that automates repetitive manual data tasks. If we get to the point tonight where I'm showing you our local AI models on campus, the guy that set the lab up, David Aguirre, right? And by the way, never really trained as a coder. You think he maybe had one Python class when he was in school. Has set up these entire workflows at our engineering center where he pulls data feeds from the robots, creates visualization patterns, cleans the data, does all this crazy stuff, and it's all done agentically and automatically. And otherwise, he would have to do these tasks like manually. Go to a database, download the file, clean the data, put it in there, create a visualization, and then feed it up to a screen. Well, he has an AI do it all day long automatically, right? So these are the kind of examples here that we're looking at. You guys can read those on your own, so I really don't need to put them in your brain. All right, there's a lot of different tools out there. Which one do you use, right? And often, if you go work for an organization, they're going to say, this is what we use. Why? Well, this is the one we could afford, or this is the one someone told us to use, or we've been using this one all along, or whatever the thing is. But if you're choosing from scratch, there are a lot of options. Now, we're going to show you this tool, Orange. A lot of reasons why we're using it. Well, number one, it's free, and very often there's very little spin up time getting to use it to do something productive, which is wonderful, right? Because it's free, it's open source, very well supported, and you can use it for lots of different types of little issues. And now you can see where our screens are taking us here, which is installing Orange. Now there's different ways to do this. All right, we're probably going to opt for option number 2. And if you're like, well, if we're going to use this tool later, why do I have to do it now? If you want to tinker with the tool when I'm playing with it later and follow along, you do want to do the install now. But I'm going to give you guys a heads up, right? Because and I think I alluded to this before. Last year when we did this, we did run into some problems, right? Okay, here's some of the problems. Some of the people opted to use the first method instead of the second method, and then ran into challenges because of the library versions and the Python versions installed on their system. I'm assuming that most of us are running Python version 3.13 or above. How do you find that out? Well, there's a few different ways, but most of us, if you followed my suggestion at the beginning of the course, we installed the Anaconda Navigator, right? And if you go into the environments tab, it shows you what your base root is here. And I don't know if it like actually tells you, um, but it should say, I think 3.13. If you if whatever it is, 3.13 I think is the version that we installed. There is a 3.14. My concern for you would be if you might have a version that is older than that, right? And I'm hoping that that is not the case. Um, and if that happens to be the case, then we should talk. It's not that hard to remove the Python libraries and add new ones, or upgrade them if you wish. It's also possible that you can run multiple versions, right? So we've talked about all this stuff before. The orange install that I'm going to prefer that you guys use is the one that's on the screen here. It is also possible to go directly to their website and download this as a discrete software option, right? Um, I did have people last year that ran into problems. One person had a machine that just would not install it. I'm going from memory here a little bit. Another person had a machine that could install it, but then when it came to running it, it was way too much of a heavy lift for whatever like antiquated, doorstop of machine they were using, right? So just a fair word of caution, right? You do need, as we start to use some of these more powerful tools, right? You will start to need a computer that is capable of running them. So generally, if you're on a Windows machine, you really kind of need to be at 16 gigs of RAM and Windows 10 or 11. And I'm going to say an amply sized hard drive with good bandwidth and a fairly modern, powerful CPU. I used to say like you should have like an i5 or an i7 or an i9. I still say that, but it could be a Ryzen chip as well. And then systems that have discrete video cards also fare better also, right? Because some of the visual processing is offloaded to the GPU, which frees up the CPU to do more work. Um, so just be mindful of that. This product can also take a while to install. Um, During the install last year, I don't remember what happened to me, but it's probably in the videos if you look back to last year's videos, if you even care. But I ran into a problem where I tried to install it and it just wouldn't go and it wouldn't go. And I thought it was going and then it wasn't going. And it turned out that the issue I was having is I had too many different versions of Python on my machine and it didn't know which one to attach to. And I didn't know enough at the time to direct it to the right one to make it work. I did eventually get it to work by doing a standalone install. So if this one fails in Anaconda, heads up, you can do the standalone install and it should work. Right. So let's go back and take a look now. And let's look at what they're suggesting first, and then we'll do it. Okay. So a lot of the slides here are kind of like this that we're going through here today. Okay, so this is method one, and please don't do this. I'm just throwing it on your radar. If you need to do a direct install, this is the methodology. There's a website called Orange Data Mining, right? You can go to, choose your OS, and download the version, right? So there's a download screen. Microsoft is going to tell you it's not safe. Mac will do the same thing. You tell it no, it's fine, right? Then you go ahead and run the installer like you guys haven't done this before, right? I'm assuming everybody's installed software at some point. Pretty typical install screens. And you just follow the process and then you start Orange and you're all happy and the world is a wonderful place. If only, right? If only it was that easy. But you know what? If you have that mindset, it's more apt to be, by the way, right? I always tell people, be careful what you wish for because it just might come true, right? So wish positive things. All right. Second method is to do it through Anaconda, which is going to be our approach. Once again, my preference here is let's look at the screens see what they're suggesting, and then we'll try it and we'll demo it, and hopefully everything works perfectly, and then we can get to playing with it. All right. So let's click through here. So you'll bring up your Anaconda Navigator, you'll find the orange product, and ideally, maybe you already installed it. I don't know, right? Some people are like that and like, look at all these things I can install, right? And I always caution people, don't do that because you don't know what you're installing or how big it is. And if you install all the tools that come with Anaconda, you could fill your hard drive pretty easily. So caution, right? Don't just willy-nilly do that. So we're going to find it. We're going to click the installer. And this is really kind of an interesting little bit here because what they're really kind of pointing out here is that you might need to upgrade the installer on the system. Now, I'm going to be really brave here and say we can probably skip this step, right? Because we have a fairly recent install and the way it's packaged should work. And I want something that works. But I do want to explain what this stuff means, right? So when you're working with Python, Python has on the command line installers that you can use to add libraries to your Python installation. And we talked about this in data analytics, right? So we're talking about like matplotlib, which happens to be included in Anaconda. But if it wasn't, you go to the website, you download it, you run the installer, and the standard Python installer is the pip installer, PIP. So you type a command like pip install, whatever the library is. And then, maybe there's some extra stuff you type. Anaconda, though, also the Anaconda distro also has its own command line interface where we can run the Conda installer. So there's a Conda install whatever, right? In this case, what this command line does is it goes in and it adds a configuration channel, which is a place where Anaconda can download the latest versions of all the libraries for all the tools you're adding to Anaconda. I hope that's not too long-winded. There's a lot to explain. But basically, just like this environments tab has here, right, where we have all these libraries that are installed, we have all these libraries that aren't installed, right, that we might want to add, right? And when we do this command, what it is really doing is it's going out to the source that drives these listings, and we're updating it so that we have the latest stuff listed. And what they have done in this environment, right? And for example, like if you do have something installed and there's an upgraded version, right? Notice how it says update available, right? And this will kind of handle it from here. So my general preference for most of you is if you're going to do this stuff, you do it from this interface because there's less problems, right? It is possible to do that updating from the command line and the install from the command line. You can use pip, you can use Conda, but I think this environment is easier for most of us. And the command that we're seeing here, right, and I already clicked forward several slides apparently, right? So you run this command, and then you run that command to install it if you don't want to do it through Anaconda Navigator. And I don't recommend that approach, right? But that is kind of like coming in here, updating the index, then installing Orange, and then it runs all the right stuff. So like when it puts libraries in, it's supposed to be like the latest, greatest, whatever. But if your Anaconda installation is fresh, which ours is, we shouldn't really have these issues. All right. So we will not do these steps, right? It'll do all this stuff. And if for whatever reason it doesn't work, then we might revert to those steps if necessary. But what I want to show you here, and what's really kind of happening on this screen, is whenever you install a piece of software, right, this is a very Linuxy like kind of thing, like, like techno geek nerd command line stuff. But when you install stuff on a Linux system, and this approach is very Linux like, you install one piece of software, and that software to work requires this other piece of software, and that piece of software requires another piece of software. and you go on down this rabbit hole. And what happens is you install one piece of software and it downloads a bunch of different libraries, different software. All of them have to be downloaded, installed, and whatever, and it'll do it all simultaneously. Right. It's kind of fun to watch it from the command line because these like progress bars, they're ASCII, they're text, but they still work like progress bars in a GUI environment. Um, all right. I guess we're done with our demo here. So if we ever have to refer to those slides in a pinch, we can use this. But we're going to try to do this directly from inside the Anaconda Navigator, and we're all doing it right now together. So I hope you guys are with me. If for any reason you cannot do the install right now, I'm going to just have you think about this. Find a time to do it where you can, or if you're not on the machine you would normally use. I get it. You can always refer back to the video. And if anybody gets stuck, I'm happy to help you out, right? We might not be able to do that during class tonight, but at some point we can get together on Zoom, maybe even after class, and we can work it out. All right, let's go over to Anaconda Navigator. I'm going to go back to the Home tab, and I'm going to go ahead and click Install Orange. And I know some of you have already done this. And what we're going to do is we're going to be uber patient. Are you guys feeling me here? We already know from looking at the background stuff that it's going to install not just one thing, it's going to install a whole bunch of things. And if you think about that process, right, the installer here is doing like multiple installs all at the same time. Last year when I did this, and you can probably watch the video, I got stuck at this step. And I'm like, all right, mine's still not working. And everybody else in the class is, mine's done, mine's done, mine's done. And I was kind of in that boat. So here's what we're going to do. We're going to let this installer run for right now. We're going to do our break right now, right? Smart time to do a break because this might take a little while. When we come back, as soon as it hits any other screen, that's where we are going to resume from. But for now, I'm going to pause the recording. We're going to do a 5-minute break, and I'll see you guys around 8:40. All right, so pausing for a few moments. All right, we're back from our break, and I'm very happy to say that this time around, about a minute after we went into break, my install was done, which is really more like what it should be. It took a little while here in the Navigator for it to run, but it completed the process. It didn't ask me any questions or screens or anything I had to fill out. It just now says launch instead of install. So I think I'm all good, right? And I'm double checking that everybody is okay. If you did not get it installed, it's not really that big of a deal. So I see like one message in the chat. So like one fix for that, by the way, is like if you come into the Navigator, you see the orange icon. It says install here, just click it, wait a few minutes, and it should be done, right? And so it's not really that big of a deal if you want to wait until tomorrow to do it, as was said in the chat there. But for right now, like really our more important thing is that we do get it up and running and then start playing with it a little bit. All right, so we're past these screens then. We didn't have to do any of this command liney stuff, thank goodness. But we're going to resume the PowerPoint here. So we have some materials to go through first before we get to the demo-y part of it. So let's talk about conceptions here before we start playing with the tool. And they're kind of reiterating some basics here, right? And I know you guys are picking up on this, but this is really like reinforcement stuff, right? And they indicate here that these types of no-code tools are basically, it says just a means to an end. It's a way to get the work done that makes it easier for us, right? So we still need to know, like, if we're doing this kind of work, why we're doing it, what's the goal of it, what's the objective, what are we hoping to achieve with this, right? All of those things. And we still have to know how to solve the problem. And I want you guys to think, okay, I did have a couple of you that came to the advisory thing. Do you guys remember like that one lady was talking about, she goes, well, people still need to understand how the business process works, it's operational. Like we're trying to solve some real and what does it say right here? Our objectives are to solve business problems, a process, so that like totally resonates here, right? It's like we're not just using tools because they're cool. We're using these tools because it's a means to like getting our work done and achieving the objective. So we're going to do a little bit of revisit here where we're going to look back at the AI project cycle. I promise this will be somewhat painless, but as we go into doing project work, you know, we're always going to come back to this model here of how AI project cycles work. I wish the graphic was circular because in most other project cycle graphics that we look at, the starting point is also the ending point, and you end up going through it again and again. Here they talk about, let's look at the grand bullets here, right? Um, uh, Problem scoping, right? Data acquisition, exploration, modeling, evaluation, and then you deploy your model. So we'll go through these one by one real quick here, right? So stage one, and this is a really big kind of goofy but important issue when you're doing project work. And for as goofy as it sounds, um, I think it's pretty interesting that a lot of people ignore this, right? It's like, well, what are we really trying to do? What's the issue here? And if you're not thinking like that when you start out a project, you could build a whole bunch of stuff and go, oh, I did all this work and I don't need it. Right. Or wait, that wasn't quite right. That's not what we wanted. Because you're not understanding the problem for one thing. So, and if you can't understand the problem, you can't clearly define it. And if you can't clearly define it, you can't come up with a good solution. Right. And it's really kind of as simple as that. I had an example recently. I'm teaching right now a web capstone class where these are my graduating web students, and they're building a website. And one of these students took it upon himself to add these features to the website that were pretty sophisticated. And then we met with our client. We work with real clients in that class, and the client's like, "Well, we really don't need that feature," and he had spent like a whole week building it. And I'm like, you know, we could have looked at our notes because in our notes originally they said they didn't really need that. We just thought it was a neat feature, so you kept working on it and you spent all this time building it, and it's not necessary, right? So scoping your problem, understanding what your problem is, and then figuring out what kind of issue we're really dealing with. And you'll get to know more about this stuff as you move forward. But is it an AI problem that we can break down into the category of classification or regression, right? Because these are kind of like basic types of problems. So for example, and you might want to answer the question for this, like, for example, is it going to rain tomorrow? Okay. What kind of problem is that? Classification or regression? Well, you guys really don't know what these terms mean yet exactly. I mean, we've talked about them a little bit, but it's surface scratching stuff. It's not really kind of deep dive. But they give all these examples. If given a data set, predict if the cell is cancerous. Given a data set, predict the house prices next month. Predict your exam scores for this module at the end of the semester, that kind of thing. And you ask yourself these questions: which category do we fit into? Because that will decide what you're solving, right? Like if you don't get like what you're trying to solve, what are you doing? Right? You're not doing anything, right? So this is why the conceptual knowledge, you guys might find this boring that we talk about all this stuff, but this conceptual knowledge that we're learning in this class will be the foundation for all the stuff that you're going to be doing going forward. And it says, have you considered what could be AI ethical problems that might arise from the thing you're trying to solve? It's important, truly. Next, we have to get our data, right? Data acquisition. Where do we get it from? Um, and I mean, this is kind of a thing, right? And we've also learned that sometimes the data is so hard to get that people end up creating synthetic data, right? And then look at all the questions. Do you have complete data? What additional stuff do you need? Is the data that you have relevant to the problem you're trying to solve, or is it for something else? Or is part of it good and part of it's not? Are there any ethical considerations for it? Do you have lawful rights to the data? Are you stealing it from somebody? That's not good, right? Data is big business. If you guys didn't know this, a lot of people, they take data and they just sell it to other organizations. Why does Google give you all their services for free? Because they're gathering all sorts of information on you and they sell it to others. Data has value, right? And yeah, some of that stuff, um, might be private data. And, is that okay? Probably not in most cases. All right. You got the data, assuming it's the right data, correct data for doing what you're doing. You got to look at it. And this is a really important thing in data analysis, folks. Just to take data and believe that it's good and real and true and accurate and clean and well formatted and all those things, you got to look at that data. You got to explore it as they're indicating here, whatever that means. You might visualize it. You might just drop it into a spreadsheet, whatever, right? But you have to examine it. Next, we get into the modeling phase, right? Um, and then we ask that question again. Is the model created for a classification problem or a regression problem? Right, very typical because these are the two main algorithm types that we use for machine learning, which train our models, by the way. And then the question is asked, what are typical models for classification? What are typical models for regression? Now, if you guys don't remember what these two words mean, here's a basic understanding. Classification is like, well, think of the image thing we did. Okay, here's a picture of an animal. Is it a cat or a dog? Right. We're classifying it, right? Is it a mammal or a fish? For regression, think of the maybe the height weight ratio thing we did in the data analytics class, right? Generally, the taller you are, the more you weigh. There's a correlation basically. So regression is like correlation. So the taller you are, typically you weigh more. Makes sense. It also, from that data set, we remember that men tend to be taller and therefore weigh more, and women tend to be a little bit shorter and therefore weigh less. Okay, that's regression, by comparison. All right. Once you decide what kind of category it falls into, notice that the regression and classification are really only two branches of modeling, right? We also have clustering and dimensionality reduction, and some of those like overlap a little bit. But you'll notice that when we try to figure out what models we use, there's a lot to navigate. You have to kind of understand your problem before you can navigate like through this graphic and figure out like which tool am I doing, how much data do I have. So if you look at this graphic really carefully, it says like how much data do you have, and that sometimes determines, is your data labeled, is it not labeled, is it structured, is it not structured, et cetera, et cetera. And that helps you to figure out which models and tools you're using, right? And these are pretty important. And I do want you to notice that they're referring here to a particular library called scikit-learn, which we will use in the future. But when you're trying to break this graphic down, and I don't know if my browser is opening this right now, whatever. Basically, this graphic comes up on the website, and they have tools there that help you kind of narrow down. So if you want to look at this graphic in more detail, you can go to that website and check it out. Finally, if you've got the models in place and you're up and running and whatever, you start to evaluate. Is it working well? Is it doing what we expect, right? And is it classifying correctly or regressing correctly or correlating correctly? And then what level of tolerance do you allow in that evaluation? Like how good is good enough? Is it like horseshoes and hand grenades, or is it like playing darts and you got to get a bullseye? That kind of thing, right? So those are all pretty important. Ultimately, if your model is well trained, well built on the right premise, you're solving the right problem and you get it, then you can deploy it, which is to put it out into the world for use. And the way we deploy, it's typically one of these three things. We build an app, right? Or we run it on a website, or we run it up on a cloud server within an interface on a cloud platform. The other option, of course, is to run it locally, like you can build it into a piece of software or whatever. It depends on the environment. Like, public consumption, an app is probably the way to go, right? Or a website. For an organization, any one of these could work, but chances are you might be working on a cloud server. And deployment means putting it out into the world or into the wild. Um, all right. So the next part of class here is we're going to start playing with the Orange data mining tool here. And we're kind of going to use these slides as a guide, but we're also going to kind of throw the guide away at times, kind of use our own intuition to play with it. So let's just kind of explore what they have here and see if we can follow along the best we can. And I always preface, these slides are somewhat dated, by the time we get them and they're published and all that. So things can change on the screen, right? Okay, here's some of the topics that we're gonna look at here. We'll get into the product. We'll look at the layout of the screens. We'll look at different ways to put widgets on the screen. So if this is all drag and drop, there's got to be ways to move the tools that were the no code tools we're using and move them into the workspace. And then as we put what we call widgets on the screen, the widgets tend to connect together. We have input points and output points, and you can take the output from one and make it the input to another. Like, so you might get a data set, right? You might clean the data, and then you might output that clean data to a visualization tool or filter it or whatever, right? And that's kind of what we're looking at here. And then we're also looking at, these other basic commands like insert file, view table, and visualization. Right. So, all right, we're going to look at some of these graphics here, and then I'm also going to bring up the product. So I guess maybe now is the time to bring up the product. So let's just go ahead and do that. So I'm going to go into the navigator here. I'm going to launch Orange. All right. Be patient with the launch, right? Depending on your machine, it might take a little while. And comparatively, I mean, my machine's not all that new, and it's like pushing 5 years old already, but I do have, a lot of capability within it. And you'll notice here that we get to a welcome screen, and I think they address that here, right? You get the welcome screen, and they point to it and say, "This is the welcome page. Thank you for explaining that. We couldn't figure that out, right?" But whatever. We're going to get rid of the welcome screen, so let's do that. So I'm just going to close, and if you don't want to see that, you can turn that off. But I want you to notice that new file, open a file, what you did recently. There's tutorials, examples, and documentation all available from that screen. So initially, you might want to leave it there. I am going to go into full screen mode here, just so you guys can see it. And I do want to point out, like, if you want to like play around with the product, you might want to do the tutorial that they have down here. I'm not going to do that right now. I'm just going to close it and get it out of the way. And then we'll just take a look at the basic toolbar here. And what I do want to kind of point out is we have this area, the big white area on the screen. This is kind of our workspace canvas, basically. There's a bunch of tools here on the left sidebar in different categories. And I want you, when you get a chance to explore all the different things that are in here. And I want you to know there's a lot of tools in here, right, that correlate to a lot of the concepts that we've been talking about, right? And we will play with just a few of these here tonight, right? We're not going super deep, but there is a lot of capability in this product to build stuff, and that's pretty important. Also reinforce the fact this isn't the only tool like this. This is just one of many. This one's just a nice one because it's completely free and a good intro to doing it, right? All right, so we have our widgets over here, and the widgets are the things that we can add to the canvas, which is the big open area over here. We're going to work on the data section first, all right? And then we're going to learn how to place stuff on the canvas. So I want you guys just to explore. And for right now, it looks like they want us to use a file, right? And so we'll play with this. Let's click a couple slides ahead. And one way to do it is we can drag it to the canvas. Um, okay, so we can click on the widget to add it. We can drag it to the canvas, or we can drag from an output to a different widget, right? And then I think there's method number 4, or you can right click on the canvas anywhere and just add the widget directly if you know what it is. So like totally flexible. And what I would recommend is just find an approach you like and use it. Often a drag and drop is good, right? I'll control Z it, right? I double clicked. A single click puts it on the screen. So that seems, I did a double click and I got 2 of them. So I'll control Z, control Z. I can also right click the canvas and do it that way. And then the other way would be like if I am um, doing an output, right, like that, it's going to ask me to do something else, right? But you see how like how easy this is? I mean, it's like, all right, whatever works for you, we got it, you know? All right, so right now, let's just leave the file thing up on the screen. Um, um, okay, do you know where the input and output, where is the input and output of the widget? And really they're attached here, right? Now, be mindful of the fact that like if I, let's say I put in a data table, you know, this is my starting point. I'm feeding in a file. Its output is now going to a data table, and then the output of that might go to whatever, a bar plot, or you know what I mean. So the input of one can become the output of something else, and the output of that becomes the input to something else, right? And conceptually, I think what's interesting here is that we can just do these drag and drop, right? I'm not coding this stuff. Now, when we work with Python, we can take many of the same actions. Think back to what we were doing in the data analytics class today, right? We were importing libraries, then we would import a file, we would read the data out of the file, and then we put it into like a data structure, data table, whatever. And then we were creating a visualization with it. And then we were creating an application that would react to it all, right? And you can conceivably do all that stuff here. Now, you don't have to do the same steps I just did right now. And in fact, I'm probably going to undo those, right? Um, so the left-hand side is the input side. The right-hand side is the output side. That's really kind of what they're trying to show you. So some widgets only have input or output. A file, if we're bringing a file in, we're not feeding into it at this point. We're just extracting data from it, right? So that's why that one only has an output, right? Some have inputs and outputs. Some only have outputs. Some only have inputs, right? And it just depends on the kind that it is. And then when we make the connection, this shows the path over which the data will travel, right? And when you're in the canvas, and be mindful, right? Like if you start getting too much stuff on the screen, well, you can zoom in, you can zoom out, right? You can move stuff around. And in some cases, you can manipulate the lines and you can make it look however you want. Usually what people do with these things, right, is they put things in ways that make sense to them. Like they'll work like top down or left right or something like that, or left right and then top down, whatever. It doesn't really, the order is very subjective, right? I don't know if you guys picked up on the fact I was hovering over one of the objects, and as I hover over it, it puts information on the screen. And in this case, the data table says the inputs data, data subset, outputs, selected data, and data, right? We haven't done any of that stuff. But once you have those parameters set, it'll tell you what data you're pulling when you hover over it. This is pretty interesting. So we'll get to that point. But right now we're learning the mechanics. All right, clear up all the stuff you have on the canvas and start fresh. We will link a file to our workflow. So let's try to do that. So we're going to put the file thing on the screen, and then we are going to get data from computer. And I'm not sure what it's asking us to get here. I forget. And I'm trying, you can tell I'm like squinting, trying to read that slide there. And I'm not sure what data will feed in. So let's remember here that if you go into the core shell, I do have a couple of data files here, right? So if you want, you could load download one or both of these, or if you have a different CSV file, it kind of doesn't really matter what we play with, right? But these might be good choices for download. So I'm just going to go ahead and click on that. We'll download that one. We'll download the next one. Of course, here's the geek in me, of course. Well, you got data files, right? What did I just suggest you guys do with your data files? Yeah, you look at them before you feed them in, right? What's in here? Oh yeah, this thing, right? We I think we've looked at this one before. This is the insurance one, and then there's also the viral thing. And both of these, right, are pretty intensive data sets. And I think this is pretty interesting because it has URLs. All right, I'm going to go ahead and convert it, but it has URLs, and then basically to see how viral certain links are. And it's got like a pretty intensive data set here, considering, right? And it's all numeric, really ugly to look at, whatever. But you guys always should do your due diligence and look at your data, right? If I don't say that enough, even if you only do it once, like I just did, I'm like, okay, whatever. And then when you need specific things, you want to try to understand them, you probably end up going back and looking at them again, right? And that's just kind of how it goes. So let's find a file here, and I'm going to be really careful here because I may have an actual lab file here. So I'm hunting for it right now, and if I do have it, no, those are the two that I have. Okay, I just wanted to make sure I didn't have like a third set of data. Yeah, I'm just verifying that I don't. So if you have those two, we can link up to one of those. So let's go ahead then and follow the instructions, right? I'm gonna clear all that stuff. You notice what I did? I highlighted all of them and pressed delete on my keyboard. And then we're gonna pull in a file, and then we're gonna click on it to pull in a data set. Now, there is a data set that's a very classic data set that's built into a lot of data products called the iris flower data classification or something like that data set. And it's already on board with the product. And I don't know if you guys are noticing. And I think for right now, we'll use that. And basically, somebody like, I don't know, 100 years ago or 50 years ago or some long time ago took all the flowers that fall into the category of iris and measured them in this way: the length of the sepal, the width of the sepal, the petal length, the petal width, and the category of the iris. And so it's a comprehensive data set on irises, and it's a classic one to use for doing initial data analysis. And it's provided with a lot of data products because it's a classic data set, and then we can throw it in and play with it and do stuff. And so right now, if we wanted, we could also feed in our own data sets if you want. But let's just go with that data set, and you'll notice that they have one on the irises, they have the Titanic, housing, heart disease, et cetera, right? Let's just stick with the iris one for now, and then if you want, you can at some later point take a look. If you're curious, right, and I just want to show you, like if I switch to Titanic, this is actually the data set of the manifest from the Titanic, the ship that sank, right? The famous ship that sank. So they have the status, the age, sex, and survived, right? So they got on the ship. Did they live? Yeah, kind of weird, right? And you'll notice that the different data types that are listed here, and I'm just kind of pointing it out, right? Like in some cases, we have data sets that have numeric. In other cases, we have data sets that are categorical. So the data that goes into this data field will say crew, first class, second class, or third class, or adult or child. And these are not numeric, these are categories, right? I think the iris data set is kind of a mix. So we have numbers and we have categories, right? And you can explore these to your heart's content. It doesn't really matter what we're doing. If you're loading up a file, I just want you to take a look at how we can feed data in, and notice that Orange has data sets of its own, which they call pickled orange data, but you can feed in spreadsheets and CSVs and other formats from different, basically tabular data formats into this platform. All right. So right now, that data set is loaded by virtue of just making this thing. If I wanted to feed in my own right now, I think you guys would be able to figure this out. You can go in there and I can, open that, for example, and I'm just going to do that, right? And you notice how it changed, and then it reads through my data set, and the data sets that we have as examples have lots and lots of columns, right? And look at all that information, right? And it shows you column names, the type they are, the role, and we haven't learned what feature means yet necessarily, but those are data points or dimensions of the data, etc. Right? So choose whatever one you're cool with. I'm going to stick with Iris, right? So that's selected here, right? All right. What's our next step? Let's go to that, right? So we do that step, and then it says get data online if you wish. So if you had a URL where it takes you right to a CSV file or a database table or whatever, like you can go right to it. You can select that. But preloaded data is probably the easiest thing that we can do. Now, the thing that we're really building, we're working with no code tools, and this is an important kind of conceptual and let's call it definition thing. Really, what we're building when we're doing these no code things is there's connections and data flows through. So we call this a workflow, right? And it says, but can we see the data, right? And so what we're going to do is we're going to connect file to a data table, and then we're going to double click that data table. So let's go back to the canvas and do that. All right, so here, I'm going to do it with a right click. If you want, you can drag it over, whatever, but I typically do it this way because I know it's there. And then I'm going to connect from here to here. So click, drag, release. All right, and that's kind of the slide. Double click on data table when you're done. And what's going to happen, right, is you should see something sort of like this. So back over here, the data's feeding in. Notice it says data right there. I'm going to double click it, and there's my data set. And you notice very exciting data. There's a couple of categories here. But I don't know if these are centimeters, millimeters, or whatever, but somebody very meticulously measured the values for all the iris flowers and put them in this table, and here we are using it all these years later. Interestingly, right, there's some tools even right here that are pretty powerful. Like, for example, visualize numeric values. Like, wow, oh, that's really kind of neat, right? Like, you can tell which ones are more prominent, and notice how like the different categories are different colors, and some categories have bigger data, basically larger data values. Like the blue ones seem to be kind of have small petals. The red ones are kind of medium sized, and the green ones are large. So that's kind of an interesting tool right there that helps you kind of look at the different categories and values very quickly, right? We're not even doing an analysis or anything yet, but this is just to show you, right? So we can look at the data in the table. We can turn off the naming and the coloring if you wish, and all of that is doable here, right? All right, let's move on to the next step. All right. Now we did this step, right? Visualize the numeric values. I very intuitively clicked on it, but guess why? Because I've done it before, right? And that was pretty cool, right? But it's not quite the same as actually making a visualization. So what they're going to indicate now is I can also take that data and create a scatter plot. So like this allows me to look at my data in a raw fashion. This would allow me to create, well, exactly what it's talking about, which is a scatter plot. So let's add one of those. All right, so I'm going to come back here. I'm going to close this dialog, right? And then we'll go back to the canvas if I can even find it. And then this is a visualization. So you could drag and drop it over, right? All right, so we can move that out of the way. And now we can create another output and connect it to the input of the scatter plot. And then once again, put that wherever you are comfortable putting it, right? Maybe that's good right there. Maybe I'll zoom in just a tad. Okay. Next step, right, is they want us to double click it, which opens up this interface. And then we can play with some of the buttons here. And they want us to click Find Informative Projections. All right, so let's try that. So I'm double clicking. It brings up this graphic, right? And what I'm going to do here, right, is I'm going to adjust this and then bring up that visual right here. It kind of looks like what's on the slide. But notice like the color categories that we saw before, right? Because there were three uh, colors, right? And for the categories, and then we plot those categorically here and their data points. So the categories are colored, and then the data XY points. And notice what the XY axis is here. Um, you know, the sepal width and sepal length, right? And then it has a little chart. And I want you to notice that we can switch those. So if I wanted to change it to petal length and petal width, it creates a different looking setup, right? So it's like, what data do you want to look at? But sepal length, and I'm not even sure what that means, sepal, somebody look it up and tell me, put it in the chat, right? Some aspect of a flower. But there's this button, right, that says find informative projections. And what this basically does is it's finding data points that might be more useful to us, like which ones really like are like highly correlated and important, right? And you'll notice that as we kind of flip through this. So remember, I did this manually before I switched to petal length and width. Here's petal width and sepal width, and it's combining all the different data points in different ways and visualizing them differently, and they all create a different scatter plot, right? Because we're looking at the data in different ways, right? Um, and a bunch of tools here, right? Like you can make things bigger or smaller, right? If you wish, you can make them darker or more opaque, right? Don't make them too opaque, right? Jittering, which is kind of like controlling the fluctuation of the numbers. This data set doesn't really jitter too much. And then you can also kind of do weird stuff like this. Right. They're doing a classification here, and they're generally saying most of the stuff in this space should be red. Most of the stuff in that space should be green. I mean, that's kind of what that is. We can also look at the plot lines if you wish, right? Legend on and off, show data on mouse hover. So if I hover, and I don't know where it's showing the data. I guess there it goes. Okay. Just being a little sluggish. But as I hover over one data point, it drills down and shows me a lot of information about that one data point. Show the regression line. Now this one has a bunch of regression lines because there's a bunch of different data sets, right? And so there's trend lines going in different ways. And then show the confidence ellipse, and this is like basically identifies with a certain degree of confidence, usually 95%, that this ellipse, for example, will be blue, that this one will be red, etc. Right? And there's overlaps and whatever. But just interesting how easy it is to just kind of manipulate it. There's all sorts of tools for selecting, zooming, and whatnot. Um, and you can kind of like adjust it, you make it bigger, smaller, whatever. But here you go, folks. I mean, you're creating visualizations and stuff without trying very hard at all, and playing with a bunch of little tools. And then, whether you realize it or not, as you play with the tools, you're learning concepts at the same time. So that's how we do that piece, right? Right. And they've they're demonstrating this all to us, and I think we've tried all these different approaches, right? All right, so now we're going to move on to a different way to visualize data, and this is kind of interesting because this is one of the advantages of this tool. You don't like that visualization? Well, let's try a different one, right? And what is the one they suggested? A box plot. So that's a box plot. Let's put it on the screen here. Let's connect it up, right? And once again, let's give it a double click. And then let's take a look at what we just created here, right? So I'm kind of expanding it a little bit and probably unnecessary. But in this case, right, we can now look at the categorical data. So they have, okay, whatever, that one's not very useful. The sepal length, the sepal width, the petal length, the petal width, right? And whatever. It's like if we were flower people, this would be important to us, since we're not, whatever, right? Um, maybe, and I'm just kind of throwing this out there if you guys want to like change your data set. If you find this one kind of boring, right? Maybe that Titanic data set's a lot more interesting to look at. So now I can go to my data table and now I'm looking at, this is the Titanic manifest, folks. It doesn't give you the people's names, whether or not people lived, male, female, adult, which class they were traveling, etc. And then, of course, all the same tools we were playing with, we can plot them. Well, that's not a very interesting chart, right? Not at all. So not all of these data sets like plot well because of the type of data that they are, right? So the people that died, a lot of crew people died, a lot of first class passengers got off the ship. And you see the kind of things that you can kind of figure out, right? Looks like if you're riding third class, you're a lot more apt to die than if you were in first class, right? So goofy stuff like that. And once again, play with different data sets if that is helpful for you. Maybe heart disease might be kind of interesting. That one does not work really well in a box plot or in a scatter plot. In a box plot, perhaps a little bit more interesting. Once again, explore, 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 try different stuff, see what it brings you. This one's very numeric. I don't know what any of that stuff means. Heart disease, we were just looking at. Housing. All right, let's just go with housing and see what kind of plots that makes. Interesting. All sorts of different ways to look at the data. Just play with it. I don't know if you can do multiples here. Nope, you cannot. Play with the tools, folks, to your heart's content. All right, moving on. All right, we did the box plot thing. And normally, like long class session, play with the tools, explore, create some visualizations, feed in different data sets. You got your own data set, feed that in. I think it's all pretty interesting to play with. But we still have material to cover here. And all right, let's set up a scenario and start thinking about like what we might do here. So let's kind of walk through this a little bit, and then we're going to take a pause for a moment as soon as I do a couple of these slides here. All right, so let's set up the scenario. Scenario is You're in an insurance company, receive a lot of insurance claims every day, but they do not know whether they are real claims or fraudulent cases. And this is a very real thing for an insurance company. Um, and some people file claims that are totally legit. Some people file claims that are BS, right? And they have to kind of weed through that. Your boss wants you to investigate if there's a better way to identify the claims as genuine or fraudulent. It gives you all the previous insurance claim cases with genuine or fraudulent tags. So, like, they've already figured it out. Now, if you haven't thought about this here, this is our data set. Let's see if I can even find it here. In the downloads, the insurance data. Right now, we could visualize this, obviously inside there, but somewhere here in this data set, they have all these. You guys notice like all these ones and zeros, and really what these are, by the way, is true false, basically, right? And so whatever the category there is, months as customers. Oh, that's kind of interesting, right? There, how many months has this person been a customer, right? And so for each individual, they're only going to check one box. So they have all that data point. That isn't that interesting. And then the other thing is somewhere here, right here. This column here is the fraud reported column. And so this one comes in as fraud. So if the ones are frauds, right? And then you look at the money that they're asking for, right? For example. All right. So that's our data set. So we try to push it back to this project lifecycle thing again, to put it in consideration. And first things first, do you get what we're trying to solve? Okay, maybe, right? What I will tell you in real world situations, sometimes people can present data and scenarios to you, and you can quickly go, oh, I know, that'll be what we do. It'll be this. And then in other situations, and this is where you also have to be brave and speak up and say, I'm not sure I understand that. How does this relate to that? Or why is this important? And you might have to ask that because it might not be your data, and this is the other aspect of it. It might be somebody else's data and they know why it's important, but you have no clue why it's important, or what it means. So we try to scope the problem first, right? Okay. Same scenario. So we start problem scoping it, right? Notice what changed between these slides? The words that are highlighted. You guys picking up on that? So like that's another skill that you come up with as a data person is breaking it down into these scenario. All right. So here we do the problem scoping. So I think there might be a couple of repeated slides there, and I apologize if there is. I'll have to fix that going forward. All right. So you have this scenario, and what you end up proposing is a machine learning model that would detect frauds. And there's certain patterns in insurance fraud claims, and to find the patterns, we will set up a model to do that. There are some issues though, right? Maybe the model will put a bias in that has a bias against gender groups or age groups or race or ethnicity, or against certain groups of certain occupations and salary ranges, right? Like, and we don't want bias in our model, ideally, but biases also exist for a reason because they're usually based on data. So you got to like take precautions to make sure that you're not biasing. Like for example, like if all females that put in claims were called fraudulent, that's probably a bias. Probably not real, right? So that kind of thing. All right. So what data do we have, right? your boss has the data, you open the Excel file, you see the features. There's features on gender, occupation, and age group. Okay, do you remove it? No, but it's important to see if the model uses this as a main feature to detect fraud, right? So if yes, you need to check more details on these reasons. And if there are reasons to believe that there are discrimination against these groups, you'll need to change your approach to using the data, right? So you got to be mindful. Like I said, I use the female example, but maybe they also say like anybody who's 25 to 30 years old that puts in a claim is probably a fraud, and that's probably not the case, right? All right. So we got the data. What do we do with it? We can clean it. If it doesn't come in clean, so it might not come in clean. We can use those scatter plots or box plots to see how they sit and see are there like data points that are really anomalous. Like most of our data is here, but all of a sudden there's one way over here and one way over there. These are ones we want to look at, you know. Um, is there data that's not there? That's possible too. Is there data that's just put in incorrectly? Remember, like we did like the thing in data analytics where um, somebody sold a beer and they didn't type anything in, or they forgot to put the price in, or you know what I mean? That's what we mean by erroneous data. All right, which model do we use? All right, here's a logic chart that you can follow. How much do you have? Is it a classification problem? Is it a regression problem? Is it a clustering problem? Or are we doing dimensional reduction, right? Then we evaluate. So there's different ways to evaluate models. And this really happens a whole lot more in machine learning where we dig into this stuff. But we have different techniques that we use for seeing if models are working well depending on the kind of model it is. And these are some of them. So we have confusion matrices, we have CA, precision, and recall, all of which can be used. And CA stands for classification accuracy, by the way, right? It's in the notes section if you didn't see it. All right. All right. So let's say, we train our model, we build it, we deploy it, and then we can run our claims in batches. And this is really common for IT, right? So we do like what we call batch processing in IT, like where we prepare a bunch of data during the workday. And then at night, when everybody goes home, we feed it into the server and the server processes it. And you come back the next day and all the results are in, right? Sometimes batches run hourly or daily. I think now it's much more common to run them like in short intervals. But in the old days, it was more common to like, we get our batch together, we run it at night when everybody's gone and nobody's using the server or whatever. Okay, all the predictions, right, whether it's fraudulent or not, humans will confirm, right? So that would be, right? So we don't want the AI model to determine if this is false or true. We want a person to also look at it and go, wait a second, no, that's actually real, or that's actually false. So you can't just build the model and then leave it alone. You got to make sure it's working correctly. So you got to keep evaluating it over and over. All right. So when we get to this point here, and this is about where I'm going to stop with the lecture stuff, I think, and I'm going to confirm this here in just a second because I'm going to look at my stuff. So I'm going to pause the video here for just. Welcome back from break, you guys. I just did a quick little break to confirm where we're at in the slideshow, and this is the point where I'm stopping. What happens now for the remainder of this PowerPoint presentation is a guided step-by-step walkthrough of completing the Unit 13 project, right? And it's a little bit more involved in the couple of things that we just played with, but the whole thing is guided with images. There might be some screens that are slightly different, and I say that like real cautiously because software changes, right, over time. But it's got a complete walkthrough. And so for completing the project work in this particular unit, start at slide 100 and move on through until you're at the end. The deliverable on it is basically screenshotting your work and putting it into a document along with narration, right? The fact that it's guided really should take a lot of the stress out of it, right? It's not me guiding you, it's the PowerPoint guiding you. But all you have to do is go slide by slide, perform the tasks, and take screenshots along the way describing what's going on. So pretty cool stuff. But ultimately, as you kind of step through this, I'm just going to click through the steps really quick so you can kind of see how much they guide you, right? You're looking at data, and you keep going, right? You do all these steps, and you'll notice the it's very very granular and building basically a whole workflow. This is what workflows look like. So we're taking one thing and feeding it into another, and it creates this, and then we analyze it and do all these tasks, right? And some of the stuff that we're building here is not stuff you've really learned about yet, but as we move forward, you will learn about those things and learn how to utilize this tool to kind of accomplish some of those things. Okay, so I'm going to exit out of the PowerPoint. That's basically done. The only part I do want to put on the screen here, if applicable, is the bibliography, which I think Google and YouTube appreciate, so they know like where the stuff comes from. That I'm not stealing it. This is academic work, and these are all of our sources. All right. So the PowerPointy thing is done. And then, as I talked about earlier in the class, we have kind of a recent exciting development in that we have our new XR lab on campus with these high-powered machines with the GeForce 5090s, and we're running AI models locally. And what I did while we took our really brief break is first I confirmed that was where the project started, which I confirmed. And then I also jumped up on our VPN. So you have to be on a campus network to connect to this stuff. So these IP addresses will not work for you without an IP account or accounts on the machine. So it gets pretty complicated. But I'm in an environment right now, and actually I'm going to go back one screen here. And this is a product that we use to basically build AI workflows, right? So this is once again, basically, I'm not going to call it a no-code tool, but this would be more in the category of low code. So it does have drag and drop tools, right? Kind of a canvas that we're working on. And you can also see that this has, kind of the same kind of like interfaces, like there's inputs and outputs, and there's a flow. And I'm trying to get my AI model to spin up here. And I don't know if it's offline right now. But I'm going to do something really goofy here. I'm going to see if I can just try to talk to it and see if I can get it to, there we go. So now it's trying to launch. So conceptually what's happening here, there's not really a lot going on in this model. This is very simplistic. But this AI agent is the agent software that's running on one of our lab computers back on campus. I have a little workflow thing here so that when a chat message is received, it goes to the AI agent. It goes to our Ollama chat model, which is running, I think, Quen 2.5 with 32 billion parameters, right? And it's kind of interesting because I can choose different models to load if I wish. And then it keeps a memory of some of the interactions. And I'm not really doing anything fancy with this. Basically, I had our lab guy basically set me up so I could just connect to the machine and talk to the AI agent for right now. And then he encouraged me, he goes, Ty, you got to go in here and you got to build a whole bunch of like workflows and do some crazy stuff. And I couldn't even come close to building like the stuff that he's built because he spent months working on it. But what he's done, and okay, so the model took a little while, so it's sitting on a machine, and the machine kind of had to wake up and load the model and get it all running. But right now, I do have a live interaction with the AI, locally loaded AI model on one of our lab computers in our engineering center in Sturtevant, Wisconsin. You know, pretty cool, right? So this is not a public internet connected AI model. It's connected to our campus network. It has access to data only on the network where it's allowed to have access. One of the things that it has access to is all of our like robots in the manufacturing center and our CNC machines, all of which are network connected to our data server racks. Data is fed into those servers, into a database. I can program this AI model to read that database, extract data, filter it. And think of all the stuff we were just doing in Orange. We can do a lot of that stuff here too, right? In a similar fashion. And then when it gets down to it, I can also add workflow objects. For example, I could click in here and I can, type in like straight up Python code, or I can have it go out to a website. This is not connected to the web or whatever, right? And this is just a smattering of the tools that are available. And the crazier thing is because I can write code that sits behind them, and I think I can write it either in JavaScript or Python or a couple of other languages. I can get really granular and do some like whatever things I can do in a program. So I can create a workflow with like a no code environment. And then I can also write code to interact with it too. What David has done with it, our lab guy, is like I said, he takes data from our industrial robots that feed into a database. The AI agent reads the database tables, analyzes the data, looks for changes in the data, then looks at all the change data and finds anomalies in the data. So like, oh my God, the servo on robot number 5 is showing unusual spikes in temperature. Maybe that's about to fail, and then if it's about to fail, he has that fail data, create a visualization on a big screen in the lab that shows robot number 5, and the little red light turns on and says, server, temperature error or whatever, right? And this is autonomous. In the past, and if you wanted to figure this stuff out, you have to go to the database, run a query, extract the data, filter it, do all of it manually. And then look at tables and tables and tables of pages and pages of data that humans cannot really process and go, where's the anomaly? And the AI is doing it for us. This is what AI brings to the table in the real world, folks. So how does that help the industrial robots? Well, if we're in a production line and one of our production machines is having an issue or failing, we can pull that one offline, fix the servo, replace the part, take a look at it, let it cool down, whatever, right? Put the workflow somewhere else and work with it. But even on a rudimentary level, I can interact with this AI model. This is a large language model. All right, so I'm saying, what is a good place to go on vacation for spring break? Completely irrelevant, right? It's not like dealing with robots or anything like that. But this is a large language model, and yes, the first couple of little prompts that you throw in, take a little while before the model kind of like heats up and the system focus goes on to that model. But check it out. It works like any other AI agent, right? And this is local and it's ours and it's free. And before the year is through, folks, you guys will be playing on these machines. And I'm excited for you, because heck, I'm excited playing with it and I don't even know what I'm doing on it yet. I'm still training myself so that I can train you guys to do it, right? So that's the fun part of it. Another really exciting little thing that I'm going to throw in, and then we'll adjourn for the night, is some of you might be aware of this, but we talked earlier on in this class about how Gateway at our downtown Racine campus technical building facing the lakefront, in the basement of that building, the city of Racine, in combination with UW-Madison and Gateway, has an electronic autonomous bus that sits in there. It's never really been deployed, but they've been experimenting with this for years, and they plan to spin it up again. And I was just asked recently if we want access to the autonomous vehicle data to analyze it. So we might have the capability to work with that data too. And that data is crazy huge. I have some examples of it, and we can actually go into the server and access it directly when we get to that point. But um, the metric I remember is like on a 3-minute drive around campus, it generates 100 megabytes of raw text files of data, a 3-minute trip, right? Um, and all that data is used by its own internal software to pilot the vehicle and run and drive and stop and not run over an old lady in the process of getting to where it's going, right? And I think it's pretty fascinating that we will have the capability to work with that stuff. All right, folks, that's all I have for you for tonight. I will see you guys 2 weeks from tonight. Remember, next week is April 6th, and we have a holiday, Easter Monday, so no class. But please make sure to move forward and start absorbing the Unit 14 materials. Because the flow of the work is not going to stop in this class. Data analytics is a little different, but this class, we're hitting it hard and we're keeping going because we have a lot of work to do. All right, folks, have a wonderful night. I will see you all next week. Videos will post tomorrow, and this video ends here.